I'm going to go ahead and share my screen, and we're going to kick off starting to talk about NLP, natural language processing within H2O. But while I'm doing the introduction, for those of you that are able, I assume everyone had a chance to go to aquarium.h2o.ai and create an account. You can watch or you can participate. If you'd like to participate, I would suggest coming and creating an account on Aquarium. And once you're logged into Aquarium, we're going to be doing the lab. It's called, you're going to go to Browse Labs and click on Lab 4, Driverless AI Training. And then at the bottom, you're going to click on Start Lab, and it should instantly give you some links. We'll be there in a minute, so let me go ahead and actually, oh, perfect. Bruna already did that. So log into Aquarium, and we'll get running on that. Now, because this is a webinar, feel free to either raise your hand or ask questions in the chat or in the Q&A. But let me give you a kind of quick introduction to NLP within driverless AI. And then for those of you that weren't able to join yesterday, I'll do a little bit of an intro to driverless AI when we first log in. And then we'll talk about how this works with NLP. So very quickly here, our NLP team lead, one of the great data scientists doing NLP is named SRK. He's very involved in Kaggle. He's been an H2O employee, a really brilliant guy based out of India. And he has led a lot of the stuff we're going to see are due to him, and some of these slides are due to him as well. So I just wanted to give a shout out to SRK, who is kind of the guru of this for H2O. Another really quick thing to talk about in general is that you know, there's a lot of talk about sort of statistical learning versus deep learning, and TensorFlow, PyTorch versus gradient boosting, etc. You don't have to choose in driverless AI. We can do both. We accommodate both. There obviously are places where deep learning works better, typically with images, video, audio, text. Those types of things are the classic use cases for deep learning. Structured data, again, a lot of the stuff that traditional statistical analysis and traditional machine learning kind of falls under things like the elements of statistical learning here. So in driverless AI, it gives you sort of a unified ability to use either of those. And that's a theme we're going to return to here. So just really quickly, and this survey is now a couple of years old. I haven't looked at it since COVID, but when people were asked what kind of data do you deal with at work, still the vast majority of data is relational data, right? The 65 to 70%. And so those are things that driverless AI we can handle with all of the IID methods, with things like time series falls within that as well. And then there's text data, NLP, so using both statistical learning and deep learning. That's what we're going to talk about today. Even though image data is pretty cutting edge, it's not used everywhere, and so these percentages may have changed. They may be a little bit higher than they used to be, but we'll get a chance to talk. I understand we're going to talk about some image recipes that driverless AI can do a little bit later during the week. So let's talk about some of the methods underlying NLP within driverless AI. And the basic idea with any type of NLP is you're taking text and you're figuring out how to take non-numbers and make them into numbers so that an algorithm can understand them and have that translation have meaning somehow, right? And so the original traditional ways where you take these text columns, you create text-based features, and then generally, so again, depending on your problem set, your problem may be pure NLP, or your problem may be things like you're building a model to predict who's going to churn, and you've got some comments. So you have a bunch of numeric and categorical features that add power, but you want to add some lift from your text-based features as well. So NLP is actually quite broad in terms of its use in predictive modeling, and this is the use case that I've seen time and time again in industry. So then you choose your modeling algorithm, and you're kind of off to the races here. And once more, there are lots of use cases for this. So like text or document classification, sentiment analysis from text. Now, the traditional ways of doing this were things like you can think of just word counts, right? Word frequencies, or what we call TF-IDF, which is the inverse document frequency by the word frequency. And the idea is that we have words that are low information but very common, are called stop words, and in lots of methods, at least traditional methods, you filter those out. So those are the and, or, but, words that generally don't carry a lot of meaning. And then we've got rare words that don't occur much, possibly or probably have very high value because they explain a lot. And oftentimes, at least in the I'm going to still call this TF-IDF, I'll call traditional, kind of old school, still very valuable, but it's pretty common to kind of filter these words out and filter these words out, and then use the rest of the words to build models with, right? And use this sort of Cartesian coordinates of where those words show up. And again, there's a lot more to it. There's stemming and making words, getting all your verbs similar, et cetera, like that. So there's a lot more kind of going on under the hood here, but just from a very high level, the traditional TF-IDF approach is supported natively in driverless AI. Now, the second one, which is kind of, I always considered this sort of magic or amazing, is the idea of word embeddings. And word embeddings, in their best, can learn from free-form text and learn relationships using a deep neural network, deep learning of some type, and there are various forms of this, to build relationships between words to allow you to have sort of an algebra of verbiage. So you can do things like man minus woman plus queen equals king, right? It creates sort of this algebra of verbiage. And it works with things like verb tense. It finds relationships, country capital. These are all things that come out without a person interacting with this. And so word embeddings are kind of, I call them sort of next level here. These also are natively supported in driverless AI, and we'll show you how that works in a minute here. So starting with our text features, and you'll see these as we get into driverless AI. There are various things we can do. So in a TF-IDF approach, right, you can take counts of the words. You do a truncated SVD, so a singular value decomposition, truncated meaning that you don't keep all of the eigenvectors, and you get rid of the lower singular values and their corresponding eigenvectors. And this is a traditional dimension reduction technique, and that will give you text features, and those we call TXT : and then we've got the feature name. Just a straightforward TF-IDF, once more, instead of just TF-IDF or count. And then using linear or logistic regression, depending on the situation there, we can come up with what we label as text TE features for various features. Or equivalently with word embeddings, using a CNN transformer, and this is how those are labeled. So again, this is sort of standard embedded and driverless AI natural language processing abilities. And so you'll see as we start running experiments some of these. So just for fun, again, a few years ago, there was a Kaggle competition that was they called it Bag of Words meets Bags of Popcorn. And the data fields were pretty straightforward. There was a unique ID, there was a sentiment, so this is a sentiment analysis, a sentiment of the review, 1 for positive, 0 for negative reviews, and then just the free-form text of the review. And sort of the benchmark here for driverless AI is how does it do out of the box in building a model for this competition? And by the way, this is something that our data scientists who help develop this often do internally, is say, well, how much of driverless AI can we make have a competitive Kaggle type model, see how well it does against others. And so as we get into driverless AI, we'll show you here that, for instance, this picture, each one of these dots corresponds to a different model that was built, and we're trying to maximize this. It looks like we're using AUC. We're trying to maximize AUC. At the end of the day, there's our AUC. The model that was built is apparently an XGBoost model. Here are some of the features that were created for this model, along with their variable importance, etc. So here's the benchmark model that was done just with some kind of default settings. And here's the thing that's pretty cool about this, just to show you the worth of it. Again, you can go to these Kaggle competitions and do a late submission and just see how you would have done. And that default driverless AI model would have been top 10, but placed between number 5 and number 6 in terms of how well it did. So driverless AI, even with the traditional using only up to word embeddings, does a pretty terrific job with that. Now, one more, if you're involved in NLP, you may know PyTorch, you may know TensorFlow, you may know both. You may have strong opinions one way or the other. So which of these do you choose? And as you'll see, there's really no dominant player here as you look at the popularity of TensorFlow versus PyTorch. They're both, pretty comparable right now. It looks like if you look at that trend over time. So which one do you have to choose? Once more, in sort of the driverless AI approach, you can use either, right? We allow you the ability to use either, and just we'll get into this. This is an expert settings within driverless AI, specifically for NLP. And we have settings for, do you want CNN TensorFlow models for NLP that are word-based? There's another kind of flavor of that, the Big-Ru TensorFlow models for NLP. Do you want character-based? So character-based would be used for languages that aren't sort of words, so Chinese characters, etc., are things that might fall under this case. Do you want PyTorch models? That is available as well, and then various PyTorch and TensorFlow options within. So again, let me check the chat and make sure that we are good. So hopefully we'll pass along this presentation. This should give you a good overview of NLP capabilities in driverless AI. So let's jump to driverless AI right now. And feel free to raise your hand. Was everyone able to get this? Oh, how to fine-tune models, change model architecture during H2O, good question. We don't give you that level at this point, right? So these are pretty, because driverless AI does this plug and play, we don't give you, maybe if you're a PyTorch expert or TensorFlow expert and you want to play around with the architecture under the hood, that's something generally that's not available in this. So, and I'll talk about where that's a great question. I'll talk about where that would come into play and why driverless AI is still a useful starting point for you at very least. So great question, thank you. So at the bottom here, click on driverless AI URL. Now we'll probably ask you here, I'm gonna log out real quick so that we can all log in together. There's a description, so I came, let me show you once more. I came to Browse Labs, I came to Lab 4, I came to the bottom and clicked Start, and then clicked on the link here. Now there are some, and we passed by them. I'd like you to log in using training as the username and training as the password. I'm not sure if that's what you used yesterday. We also have so many experiments in this that we've separated them into some training and then some healthcare related trainings separately. Feel free to come back and revisit and look through these. So we're going to log in using training and training. And my browser is going to warn me that this this password is been hacked and known, and I'm going to not care about that. So let me quickly, and apologies for those that attended yesterday, I'm going to give you just a very high-level overview of driverless AI for those that missed. This is what driverless AI looks like when it's been pretty heavily used, right? So we start out in the datasets tab. We have a number of tabs here across the top. We've got projects, datasets, AutoViz for visualizations and experiments, diagnostics, machine learning, interpretability, deployments, etc. So there's a lot of stuff here. I suggest you go listen to the recording of David Engler's session yesterday. He knows the instrument very well and is a very accomplished data scientist, so he's a good person to listen to on that. So data sets, we can import them here from driverless AI. These are called connectors, and so in our case, we've got connectors to different systems. You can connect to Amazon S3, file system. You can upload a file from your own setting. You've probably, there's a Hadoop file system. Internally, you may well have other connectors that we don't show here. And once the data is loaded, and let me come, I'm going to come, I think, to page 4. We're gonna start out. I'm going to show you a sentiment analysis, which is Amazon Fine Foods Reviews is the name of the data set. This was became a Kaggle competition and is open source data as well. If I click on the data, I have the ability to, let's look at details here because we're going to use this experiment anyways. In details, I get summary statistics of each of the columns. We're interested in predicting whether a review is positive or not. So this is going to be our response variable. We've got a description. We've got things like time, this thing called helpfulness numerator, profile name, helpfulness denominator. We've got the score of how much someone liked something, and we translated that into ones or zeros. We've got summary, ID, product ID, and user ID. But the thing that's interesting is this description. This is the text. If I want to just kind of look at it as a data set, we can see here's the summary, scores, etc., and then you can start to see the descriptions as you kind of highlight over these. You can read it a little bit. So this is the that was the first thing we looked at, was details of data. Give us a chance to look at the data. Visualization is for auto visualization. I'm going to skip that for right now. Split is how you split the data into training and test data sets. That's something that we're going to want to do every time, and I'm sure this audience realizes that. The split functionality is pretty straightforward. Let's skip over that so that we can get to predict, right? And so building just a, let's build a straightforward predictive model here. And so I'm going to start with my training data. I'm going to click on reviews train. That's this, as I split, let me show you this really quickly. We had 17 megabytes total. I used our split functionality to split the data into a train and test set. Once that's done, I'm going to click on my training data set and click predict. And you get this. You notice that the data set that we're using is reviews train. The first thing I would suggest you do is click on the test data set, and let's find, oh, I need to change pages. It's towards the end here. Let's do the reviews test. So I clicked on page 3. Click reviews test. You always want your test data set in here along with your training data set, and we'll show you that in a minute. Let's select the target column. The target column is going to be positive review. And because that column is Boolean, Driverless AI realizes this is a classification exercise. We happen to be on an instance that has GPUs, so we've enabled GPUs. By the way, if you have GPUs available for any NLP type work, GPUs will offer significant speed ups.
David,
let me look at the.
There is a question here asking, what is the limit when uploading data?
So that's a great question. I'm going to push that off on, I'm going to make that an engineering question to talk with our engineers afterwards. Let me explain that. If you've got terabytes of data in Hadoop, and I don't know whether that means 2 or 50, right? But whatever terabytes of data in Hadoop means, driverless AI can handle up to very large sizes, given the hardware that it's put on. So typically, all of the driverless AI stuff is pretty much done in memory. And so it needs a really big instance, and I don't know how big the instance is that you're using. So let me actually address that here in a couple of ways. Great question. I'm not avoiding the question. The answer is I don't know how much memory you've got in your particular instance. And so you may not want to import all of your data to do this. You may want to sample, and we can help you sample, et cetera. So again, great question. Let's raise that with the engineers and find out what data capacity your individual installation has. The installation here in aquarium is not going to have terabytes worth of ability because it's a pretty small instance. But really good question. Thank you. Okay, let's see. So where was I? Oh, up here we've got validation data set. Let's click on dropped columns, and let's just drop, for right now, let's drop everything but description, right? Let's make this a pure NLP exercise where I've dropped the whole thing except description. So we're going to let NLP rule. Now, as I mentioned before, so for those of you that have not seen driverless AI before, we have these 3 different dials or knobs, and each of the knobs can go from 1 to 10. We have an accuracy knob, and that started at 7. I'm going to remember where it started. We've got an accuracy knob, we've got a time knob, and we've got an interpretability knob. Accuracy basically is, so let me pause here. Accuracy is an unfortunate but needed term. And let me explain what I mean. We're going to use AUC as our score here. So I'm just going to come and select it so it stops blinking at me and asking me to determine a score. AUC is the default score on most classification exercises unless they're pretty imbalanced. And then we use log loss as a default. But as you'll see, you've got multiple choices, and you can actually import your own custom score, and you'll probably learn how to do that later this week. So accuracy here, even if accuracy is 1 at its lowest setting, we're still going to build the model with the best AUC. So accuracy doesn't really refer to, am I going to get a good model or not? We're going to always give you the best model we can. This accuracy actually does 2 different things, right? And those 2 things are how feature evolution occurs and what my final model is going to look like. Is the final model going to be a single model chosen among multiple candidates? Is it going to be an ensemble model, ensembling a number of different candidates? How are we doing that? The higher, in general, the higher we put accuracy, the more, I like to think of this as maybe granularity or effort. Effort is maybe a good word. The more effort, computational effort we're putting into it. So for instance, with accuracy low at like 2 or 3, the model build process will end quicker, partially because in our feature evolution, we're going to do a validation split. A quarter of the data is going to be set aside for a validation split. As I make that higher, we're going to end up doing cross-validation rather than a validation split. So this accuracy knob, to a great extent, determines whether we're going to do cross-validation or whether we're going to do validation itself. You can override that. You can actually import a validation data set. And if you import a validation data set, then the cross-validation is basically off the table. So there are multiple ways in expert settings to change that. The other thing that high accuracy does is it will tend to blend or ensemble multiple models. And the higher the accuracy is, the more computational effort is used. And generally, rule of thumb is that is associated with, I would put higher accuracy when the data sets are larger, or when I'm doing something complicated, and NLP, one could say is potentially pretty complicated. The time dial, and I apologize for the review for those that were here yesterday, the time dial just tells me how long I'm going to let my features evolve. So under the hood, we've got an evolutionary algorithm. If you remember the multiple, if you remember from here, and let me kind of move forward. we had sort of multiple dots. Let's get to where the model build was. And we'll see this in a little bit, but every single one of these little dots is a separate model. And the evolutionary algorithm is saying, hey, this model, you know, there's some dots down here that did terribly, didn't do very well. Those models or those features that were created in those models will die out, and these features that are doing better get promoted and live to evolve further. Right, so that's the notion behind this. And time just lets driverless AI know how long do I want that evolution to occur. So in this case, it's going to occur up to 72 iterations. Excuse me. We're going to put early stopping into play. So after 5 iterations of no improvement, we will stop. As I make that time bigger, I can make the time here up to 9. This will go to 332 iterations, and the early stopping is going to be after 30 iterations. So it's going to take longer to stop. You should feel free as you're working and experimenting with driverless AI to move these knobs around. My suggestion from experience is, first off, if you dial both of these up to their highest level, because you figure I always want the best model and take the most amount of time, you are likely to end up with a model that is overfit and may not work as well as something closer to the suggested model, which was, I think in this case, 746 or 747, whatever that model was. So, and we'll show you how you can check these models versus a leaderboard. We'll do that in just a minute here. Lastly, interpretability. And again, for those that were here yesterday, hopefully this is good review. For those that weren't, the whole idea behind interpretability is it's kind of the inverse of complexity. The higher this value, the less complex my model is, to make it easier to understand. So these are the settings, and if I want to just go ahead and launch an experiment, I'm going to move accuracy down a little bit here. Let's go ahead and just launch this experiment initially. We're going to see it start to spin. We're going to see our CPU and memory usage come across. It's doing some initial work, and it's going to have to actually, because this is text data, here we'll click on notifications. We just noticed an indicator there, something is up. That's going to tell me, okay, data is slightly imbalanced. Target class fraction, 76% imbalance rate of 1 to 3. That's kind of informative, probably not very relevant right now. Let's see, there may have been another notification that come up in the meantime. This is going to tell me these notifications are useful here. Let's give it a second for it to start building its first model. And once the first model happens, then a number of additional models are going to continue to occur. Okay, so the first model it's going to try is an XGBoost gradient boosted model based off of the features. So let's give it just a second here. Oh, one more notification perhaps. Okay, we'll talk about what feature brain means in just a minute under expert settings. Well, while this is, there we go, there's our first model, right? So 51 different features. The first one is cross validated TE based on description. So all of these are going to be text type features based on description, and it's going to work away here and Each one of these models is using slightly different features at each one of these iterations as we're going down the line. But, and this is really common. This is the kind of the fun thing about doing NLP is it's very common for it to suddenly find a feature, right, that, now this one feature is doing a really good job. In fact, hopefully we start adding additional features here as it goes. But this kind of jump in AUC is something that we kind of consistently see. Really quickly, so this experiment's being run now. What we're running, we call these experiments because we're building multiple models. So rather than model build, we call the entire thing an experiment. And you'll see that we have pages and pages and pages of different experiments for different data sets. And so organizationally, it can kind of be a mess. So we've created this projects tab. And projects allows us to gather similar experiments into a grouping. So you're going to have to go to page 2 and come to Amazon Find Food Reviews. And I just wanted to show you a couple of things here while we're actually still building that model. As a matter of fact, once I've created this project, I can start linking experiments. So I'll click Link Experiment. And this model that's currently being built, I'm going to link to it. Oops, I don't need to link another. So now I have some models that are built. I can select here, because this is sort of a leaderboard. Let me go ahead and select these models that have completed. I'm sorry. Let's select the scoring data set to compare them to. So we'll compare them all against the reviews.test data set. Let's have the scorer be AUC. You could choose any of these. And these have already been scored. And so, by the way, just we'll compare these. The reviews baseline at 728 was for this data on a much larger instance. And you'll notice this is baseline means I haven't turned on any special NLP stuff, right? Once that model is completed, it took an hour and a half to train that model. So we're not going to sit here through the training of it. That one had multiple GPUs. Its validation score was 0.8729 and its test score is 0.8853. So again, comparable on the validation and test score. And then TF, this reviews TF is turning on TensorFlow. The reviews PyTorch is turning on PyTorch. And I'll show you how to do those settings. You'll notice both of these took approximately 5 hours. So once you get TensorFlow and once you get PyTorch working, that's going to take significantly longer. Typically, they will do significantly better, but there is a lot more computational work going on behind the scenes in each of those cases. You'll notice that in this particular case, PyTorch built a better model than TensorFlow. Now, these again are just automated builds right off the bat. And so the PyTorch model here seems to be the one that did the best. Let's go ahead and compare these three. So if I click compare, I actually get a chance to see, and PyTorch did really, this would be one I'd come back and look at and try to understand what it actually did, because with one feature, I don't want to say I don't trust it, but it may well be overtrained. That would be something that we might want to come back and investigate. You'll look at how the TensorFlow did. TensorFlow is very similar. It most of its value is in two big features that were created, and then some other features add a little bit of color to it. And then the default one has a whole bunch of kind of various features that were created. But this gives us a chance to compare these models side by side and look at them. So let's see. It looks like we've got a question. You know, a good question. How's the model architecture differ across TensorFlow and PyTorch? Let me say I don't know, but I will get we'll get SRK or one of his team to describe what that model architecture is. My guess is that it's documented, but I'm not positive on that. That's a good question. Let's see. Oh, did I miss another one? No, that's the same question. Good question. I'll have to find out. There are probably people on here who are, so I should say one of the things that's great about driverless AI is it makes NLP accessible to those of us who are, let's say, more classically trained in statistics and other things. It gives us the ability to build these types of models, which is, you know, a huge benefit for those that know how to really go to town on one of these. So let's look at this review's TensorFlow model. If I come to the model and click on these three dots on the right, I can say new model with same parameters. And that will show me exactly what those settings were in this TensorFlow model. We'll come to expert settings and we'll come to NLP, and we can see what was turned on and what was turned off. Now, as of this version of driverless AI, and this is 1.9.0, PyTorch for NLP was experimental. I believe 1.9.1, it's moved beyond that. Couple of things here. So we've mentioned this before, TensorFlow models for NLP. If I move something from auto to on, auto means I'm going to let driverless AI decide whether to use it or not. So driverless AI decides. On means go ahead and use it. Off means it's unavailable. I probably could have turned this to off and it wouldn't have changed things. Now, for both TensorFlow and for PyTorch, if you have pre-trained embeddings, what's happening currently is that we are training based off the dictionary of descriptions here. So we are creating word embeddings from scratch. And there are some cases where that's really valuable, and I would suggest you do that. So for instance, my experience at both a bank and insurance company doing this type of work is that if you're looking at the notes that one of your call center agents makes, they have a language that's different than like the dictionary English stuff. And so given different text, I actually, it's computationally more intensive, but I like training based on the source dictionary. If the dictionary is just standard English dictionary, whatever, you can download pre-trained embeddings, or you can build them once and then reuse them. That will make things much quicker here for both PyTorch and for TensorFlow. And there are some high quality pre-embedded features that you can download off of Google and various other sources. So there's lots of good quality stuff there you can get. But you'll notice that the ons here turn things off. Auto says let driverless AI decide. If you turn it to off, you're not allowing driverless AI to use it, regardless of what the features are. So this gives you sort of a rough view of the architecture, but this isn't, for those that know how to go in and like tune an architecture and do work at that level. We don't have that capability within driverless AI. So what would you use it for here? Well, you know, generally, like a lot of things, driverless AI is really great at building baseline models, and then you can tune it and build another baseline model. I would start, and in my work with regulated models in general, I use driverless AI to discover everything it can. And at the end of the day, I may, for regulatory reasons or other reasons, I may have to train it in something else. But driverless AI has pulled all of the insight out for me, and it really speeds up my process. So that was actually a great question. Let's see, are there any no other questions there? So as we go through and look more recently, we have been doing some work on how do you interpret what is machine learning interpretability for features that come out of TensorFlow type models or NLP models in general. That's a really difficult. Let me come back to projects here. That is a really difficult question, is how do you interpret these at the end of the day? Now remember, the whole purpose of driverless AI is to build predictive models, right? To predict something. So generally, even though the world of NLP is much larger than this, generally that's its purpose. When we're in some ways doing sentiment analysis is among the most complex, because you're giving it pretty much just text data and having it do feature engineering on that. Let me ask then, are there any questions? Or any additional questions? So if you don't know what you're doing and you're a naive user and you include a text field, driverless AI will automatically do NLP in sort of a TF-IDF approach. If you you can force PyTorch and or TensorFlow by turning those on via the expert settings. So once more, expert settings we get to in the model build process. So as I'm building a model, I come down here in expert settings. Expert settings cover a lot of other things as well. But in terms of NLP, there are just kind of a very few settings that one can play with in order to do it. Things like the maximum TensorFlow epochs for NLP, accuracy above enable TensorFlow NLP for all models. So if our accuracy were higher and it saw text, it would do NLP, etc. A maximum sequence length for PyTorch NLP models, 100. So those of you that know what you're doing, this isn't the architecture per se, but this does allow you to do some tuning. The default values are actually pretty good, especially pretty good for baseline. And as you saw from the presentation, one of the things that we always try to do is benchmark in sort of real cases and say, hey, how does it, and by benchmarking here, I mean, if I'm a naive user of driverless AI, would I build a reasonable model? And in essence, that's one of the things that driverless AI gets tuned to. So let me stop there and give you time back, but I'm available for questions here. And also, we will get some of our NLP experts in to answer things if they go beyond my particular NLP depth. So any questions? Oh, another question. Oh, great question. Pre-trained BERT model. So let me answer the first one. How do we deal with imbalanced data? By showing you some of those settings. Can I load pre-trained BERT model? I don't know where we stand in doing that. I know that that is on our NLP roadmap. I'm not sure. I know that we can it's possible that it's here. I don't know. That's a great question. So that's number two. But how do we deal with imbalanced data? That is another great question. So let me show you the settings that allow in expert settings. Let's assume my data are imbalanced. And actually, once you get in expert settings, this is where you guys that are experts, this doesn't freak you out. There's a ton of stuff here. We've generally hidden this from people that that would think you have to set all of these. So let's look at imbalance, because imbalance experiments are one of the most common that we come across. And there are sort of multiple ways of dealing with imbalance, and we leave that up to you. But the first thing I would look for is we've got sampling methods for imbalanced binary. And by default, that's turned off. You can come into expert settings and you can turn that to auto. And what auto will do is if, and here's the setting, if I have a 5-to-1 ratio of majority to minority class, it's going to kick off my imbalance sampling. So it's going to sample to help correct for imbalance. And the nice thing about doing it here is then all the calculations, it does the reverse calculation, et cetera, so that you're all good. And again, it's just a little bit of algebra, but it just does some of that accounting for you automatically. If you are particular to either undersampling, which is downsampling the majority class, or over-undersampling, which is upsampling the minority class and downsampling the majority class. You can pick your particular one here, or you can do auto. Now, I have spent a lot of my career working on fraud-type problems where you have extreme imbalance, and this literature over what to do to correct imbalance has been around for a long time, and there's no consensus yet. So the nice thing about the general consensus is if it's really rare, you want to do something more like this. If it's imbalanced but not severely imbalanced, then maybe just do this. Or some people say, well, my algorithm's good enough, I don't need to do any of it. The nice thing about driverless AI is I can be an empiricist, and I can build one using auto, I can build one using over/under, I can build one using under, I can build one turning it off. And using that leaderboard, I can compare them. And frankly, I no longer have general rules of thumb because I've seen enough cases where my rules of thumb have gone wrong, that being an empiricist and being able to calculate and doing the right thing for a particular problem has is what I currently do. So here we'll set this to auto. That's the first thing. The second is, so we've got a 5-to-1 ratio. These are the ones I would typically set. A 5-to-1 ratio for kicking off any kind of imbalance. A 25-to-1 ratio means it's severely imbalanced or heavily imbalanced. And this, if you turn this on, I'll have to check the documentation. I believe it will go to over undersampling in that case, but there's an additional, there's some additional expert settings, and that comes under, let me bring you to what we call recipes. I don't know if you've had a chance to see recipes before, but recipes allow us to have really granular control over what models we're going to use or not use, right? These are just, if I turn something off, it's just no longer available. If I uncheck everything and I say, oh, let me use these special versions of imbalanced GBM models, imbalanced light GBM, imbalanced XGBoost GBM. These tend to work really well with extreme imbalance, and you can leave the other setting to auto. This, and again, these are well documented, and in practice they're well done. But I can turn these on, and then the only thing available, if I say enable these, if I say done, those are the only models that have been selected. Then in terms of, and we'll come over here in just a second, and it will show us what models are being used. The only thing available is imbalanced light GBM and imbalanced XGBoost GBM. So special imbalanced versions. So to review, we have imbalance sampling things that one can do, right? We have imbalance, so we'll do that. We'll come over here to recipes and models. We can specifically select imbalanced models. Let me check everything here. You'll notice, by the way, if you want control over TensorFlow or the different text algorithms that are available in PyTorch and TensorFlow, this is how you select those individually. Again, our documentation should go through at a very detailed level how to use these. Recipes, by the way, also allow us to pull in code for other models that didn't come prepackaged with driverless AI. But all of these NLP models, so we've done a ton of work on NLP in the past year in improving driverless AI. There's a lot more available than there used to be. And this frankly gets beyond my depth of knowing advantages and disadvantages of each of these models and how I might want to choose or not choose them. So at the end of the day, you've got a lot of control on that. And I believe, let's click done here. I believe under NLP that if your BERT model is a PyTorch NLP model, I believe that this is how you load it. Great question. Hopefully the answer was useful. Are there any other questions? So let me show you, again, one thing that you should note is compared with other model builds, once you turn on PyTorch, so once you turn on PyTorch or TensorFlow, computational effort's a lot higher. It's going to take longer, and that's fine. It's typically worth it. Just in general, NLP takes longer than purely numeric problems. Another question here. So right now, unsupervised learning, NLP is not available in driverless AI, as far as I know. Driverless AI is a predictive model engine, right, that builds those. So unsupervised learning NLP currently is not available. We might be able to trick it into doing it, but I'm not sure. I haven't played with that yet. Question number 2, my guess is no, but because that's the first time I've heard that request, but I'm not familiar with what is on. And in fact, Bruna, it may be helpful to sometime this week to pull out the driverless AI roadmap, and specifically the NLP roadmap, because I know that there are a ton of things in the NLP roadmap. I don't know where we stand on that. Again, great questions. You're way beyond me in depth. Okay, other questions? So hopefully this has given you sort of a flavor of what driverless AI can do, and how it works with these types of models. Again, driverless AI's purpose is not to replace a PyTorch or to replace TensorFlow, but to leverage those in building predictive models. And so those of you that frankly even build neural nets from scratch, maybe outside of TensorFlow and PyTorch, this may feel fairly simplistic, but it's very powerful in its application, at least in terms of solving business problems that I have had experience with putting multiple models into production. And this type of NLP has been hugely useful. So let's see if those are the questions. Let me give you back about 20 minutes. Thank you for joining.